This is about automatic sequential using timers. Uh, this was the circuit before from the semi-automatic sequential. I will just change the problem to automatic. I will do the previous operation. Okay, then we will decide the sequence 1, 2, 3 by a push button. So we call this one semi-automatic because we are using push button. But in automatic, we will use timer here so that the transition from this operation to this operation is automatic. Automatic means no human intervention, no operators guidance. Only the timer, the timing device will start this circuit, then followed by this motor number 3. So we'll change that one to automatic, and motor number 2 will start after how many seconds, and followed by motor number 3. You have to remove this first. You will add timer. This one with switch on delay, the other one in switch off delay. They are opposite. This one will time, and then the contact will start turning on. This one is the opposite. It will operate first the contact and it will turn off. This one will function, then after the time setting it will operate its contact. So we will use this one. How many timers? We need 2. We will just move this one. Okay, the numbers at the bottom, this one, you may wonder if it was already explained in the previous circuits. This one is normally open, and you can found them at line 4, 14, 15. So the line 4, one normally open of M1. This one. Line 16, you can find M2. Line 16, you can find M3. This is line 16, eh? So because this will create lines when you do vertical lines. That's it. And when we are going to place normally close contact, it will be also here. So we'll use first this timer. Then by replacing this one with timer, because we are not going to turn that one manually. We will label this one as timer 1. So timer 1 or T1. T1 will place there 3 seconds. Depends on the actual design, and this will be T1 contact. So notice they have different contacts from the auxiliary. So this is the symbol of time delay on delay contact. The opposite one is like this. The symbol of somewhat like a parenthesis is from facing left side, while this one is facing right side. Next, we have to operate. There are error here, but that's problem. Not a problem. Long as it is not red, We will do that later. After some time, this one will turn on. Okay. Then what we are doing here, we will do to the other side. Another timer. This one will be timer 2. Then we will change this one to timer 2. Normally open contact because we are making a circuit. So when you are going to turn on a circuit, just normally open. You are going to break a circuit, just normally close, or break switch, normally close or initially close contact. Timer 2. Okay, we'll try. We'll solve this one. Because we moved this contact a while ago, just delete. Do it again. Turn on the 3 circuit breakers. 3 seconds. This one is 5 seconds. Okay, now if we are going to cycle the operation, we can have the option to cycle the operation, meaning it will return to timer, motor number 1. 1, 2, 3, then transfer. But we are going to change the operation by modifying it. Say, turn off, then transfer her on. So we will simulate the overload relay. Here, wait, here, then turn off the CB. We have the 3 alarms. Do not reset the overload relay, find the trouble of the motor, or turn off the main power. I'm going to move this one. We will add timer, last timer here, and we will see what will happen. There are several solutions for this. Since we are going to sequence this one on, off, on, off. So we are going to interlock this one with motor number 2. The timer, okay. Bring this down for more space. And this one interlock with motor number 3. Motor number 2. Motor number 3. You will try to see what will happen if this can cycle. Some operation will cycle, some will not. It depends on the actual location of the contact. You will try this one. There are several solutions for this. Okay, you will wait for timer 3 then. In this case, we have to transfer here. what we need, what we are doing here, normally open. What we are doing here, normally open. So chances are this one will transfer there. The normally open here is in parallel with this one. You will see. You go this way and this will be timer 3. Timer 3. Let's say 3 seconds. Time T3. On. Motor 2. Motor 3. Now, what happened here is we still have this one in operation. So there is the time that they have the same operation. So do we need normally close of M1 here? You will see. M1. Okay, it's possible. Turn on the motor. Okay. You will find some conditions that is not allowed in some cases here. If this one in operation and you will start this one, it should not start. We will see. Because you have the push button here. See, there is a time that they will operate that instant. In this interlock cannot handle that one. There will be some problem in reality if you apply this one in, let's say, forward reverse, you have complex. You should open this one first before turning this one. So that means you will have that circuit. See, this one is open only by this one. So possibly there is a, you cannot see here, but in actual sometimes there will be short circuit if you are having a complex wiring here of forward reverse, or in line 1 and line 2 will connect together. So the safer one for this is to add an auxiliary contactor. That means you're going to turn this off first. You're going to turn this off first, or finish first the operation here and transfer there. So there is no way that this one will act first, that one open one. So although we don't have the timer here, so we need another timer. You can use also the normally close of this timer. Placing the normally closed timer here is not possible, because this won't operate. Wait, open circuit. we can place the overload relay here. Remove from this side and do it here. Example this one, table order. All overload relay must be in series here. We will not place it here because this will not turn off the timer. We make it this way so that the timer contact will turn on this one. Since if we are going to connect this one here, in reality they will turn off altogether. There is a difference between this one here and here, because sometimes the normally closed timer is placed here. So we will practice this way. This will off, this will off. So altogether the supply is cut off. So we need to have this one operate first here and cut off that one. There is a millisecond difference in reality. It looks like this. This one. Okay, here. Oh yeah, they are similar. If we are going to see closely, the electromechanical contact is like this, or like this. So there is that middle location wherein the contact, the two contacts are open. So that is closed. If you pause this one, it will travel at that distance. So the two contacts are open. So this one will open first, and it will take milliseconds for that contact to reach the other one. So this one is open first. So that one is open first. If that one is open first, so both supplies are cut off. So usually the timer contacts are placed here. When you turn off the circuit, the double interlock system is better. So it's better to have the double interlock here. The timer in C contact here and in O contact. There is a millisecond difference because they are electromechanical contact, so dependent on the transition. So, okay. In this case, we don't need the timer here because we don't have complex motor wiring. We don't have forward reverse there. So no need to add the timer. If you have forward reverse or complex wiring here, well, that will be dangerous. Forward reverse line 1, line 2, line 3 can be short circuited. At that instant when this one is turned on, this one is turned on, and you are only having one interlock. In reality, you will have that symmetrical short circuit. Something it will occur between the transition of the two contactors. Because this will open first when this is already turned on. See, in bi-step operation, we'll change this one to 1 second. So you can see that in step first. 1, 2, 3, 4. You see the time. You have to click this one. See, they're operating simultaneously at that instant. You can see that one. If there is no forward reversal, the wiring here is fine because there is no time. The power circuit will act together. Sometimes you cannot see that one, but in reality, it will close that way. So better to place that one there. That's too high. Do it again. Step. Turn this one. Okay. And practice here. Step. Sometimes you cannot see that there, but in reality it will have. You will hear big impact because there is that instant short circuit. Sometimes the circuit breaker will trip off if you are having a forward reverse connection. Because two lines there will be short circuit because you are maintaining two lines. When you maintain one line and interchange the two lines in forward. So better to connect this one here. That's it. Thank you. Please subscribe and have a happy day.